Wave if you can hear me. Okay.
But it looks like you
So
can't hear us.
let's wait a little while. No, I can't hear anybody else, which is weird. Got my sound up.
Hello, Dave.
Let's reconnect the audio.
Yes, we can hear you, Dave. So quick check, can people hear me actually?
Yep.
Okay, thanks. So if you're using macOS, you can hear us. Right. So just figuring out some audio problems. Just a moment.
Hi, everyone. Can you hear me?
Yes, we can.
Okay.
Still waiting for Dave to get his audio working. Just a moment.
Did somebody mute me? Because I was muted, but I still can't hear anybody.
Yeah, we can hear you now.
Okay, but I can't hear anybody else. So there's no incoming audio.
Huh.
It says I'm getting 15 kilobits per second of audio in and nothing's playing out. So Dirk, can you share the slides and I'm going to reboot.
Yes, okay, just a moment.
I'll be back in 3 minutes, okay?
All right, yeah, let's get started. Actually, what we could have done during this audio test was to think about a note taker. So you still have some time to think about it. Okay, yeah, welcome to ICNRG at IETF 110. Yeah, I'm the co-chair. My co-chair Dave Oran is currently reconnecting. Yeah, quick information about the online participation. All the slides are uploaded in the data tracker as usual. We just use the Meet Echo queuing system. So if you want to say something, try to join the queue. And also feel free to use the chat to do your presentations so that we maybe collect technical questions and so on. I just noted that this link here to the CodeMD is actually not correct, it seems. I think the display text is okay, but if you click on it, you are arriving at, I think, last meeting's notes. Just as a caveat. All right, we are operating under the IETF IPR disclosure rules. So in essence, this means if you're aware of any IPR related contribution in drafts, presentations, discussions, you are expected to let us know soon. This is the note well and some notes on privacy and code of conduct. So the IETF has a privacy policy. The IETF has one. We advise you to check that. We yeah, generally work with each other in a respectful way. If you have any issues, there's an ombuds team that you can contact. And yeah, please also observe the anti-harassment policy of the IETF that also applies to the IETF. Yeah.
I'm back. Okay, sorry to interrupt. I'm back and now I can hear everybody.
Okay, fantastic.
Something weird on my computer because I rebooted and it's fine.
Great. Yeah, the IETF is a internet research organization. So we are working on longer-term research issues related to the internet. It's important to note that we're not doing standards. And sometimes you see RFC published and so on. This is typically for documenting protocols, for example, for experimental purpose. So don't mix this up with the standards track RFCs, for example. Here's a link for an IETF primer for IETF participants. Okay. The usual infrastructure, please join the main list if you haven't done so. For this meeting, again, we need a note taker. And so in previous meetings, Marie-José has helped us a lot in taking notes. I hope we can find someone else today. Any volunteer? So Dave, there seems to be some echo from your side.
Let me mute.
Okay. So we're sorting out the echo problem. Can we also sort out the note taker issue? And Marie-José can't do it today. So, not all at once. Great. Thanks a lot, Cedric Westphal. So Cedric volunteered on the chat. We appreciate. Again, this is just for taking notes for the questions and for the discussion. Okay. Agenda today, few interesting items. So we can tell you a little bit of about what happened recently on ICNRG drafts and so on. Hitoshi is giving us an update on CCN info. We have Yanis talking about decentralized data delivery markets, and Marie-José has a talk on ICN for IoT. And in the end, we have some important announcement for ACM ICN 2021. Okay, so this is quick update on our ICNRG documents. So the ICN LOPAN draft got updated. So if you remember, there was a discussion about how to deal with time values, and we had some plans to kind of unify the time TLV specification, maybe also updating the CCNX specs. So this turned out to be a bit difficult, and also as a risk in terms of holding up the publication of ICN LOPAN. So the authors have addressed it and submitted a new version that doesn't have dependencies on any other updates to CCNX. Schenk, if you want to say a few words about this, let me know.
Yeah, I can quickly say something to that. The main issue was that we had a normative dependency on the CCN time TLV draft that we also have. Since that is a draft, well, it would like block the queue when finalizing the review. So we instead went with the official time TLV. There's another RFC. I forgot the number now, but it's called time TLV. and reference that instead, which also makes more sense. Now it's again back at the, I think Colin Perkins received it again, and it's now progressing.
Yeah, great. Thanks for explaining that. Right. So yeah, we will work with Colin and the IRSG to move this forward. Okay. The QoS architecture. Yes.
Yeah, I have to admit I haven't had a chance to read the updates here in detail. I suspect it's probably ready to move forward. I will hope to get to it within the next couple of weeks.
Yes. Yeah. Don't worry. So we also didn't push this as much as we should have, but let's get it out now. So we read it and we think it's ready, but yeah, please check it. Okay, the QoS architecture one. This is a informational document that talks about the new opportunities for quality of service in CCNX like ICN protocols. So that is essentially done currently in the RSC editor queue. The NRS documents, so requirements and considerations, are basically in IRSG review. So we got some feedback during the review, and they also are working on a new version for the requirements one. And I believe the considerations draft is currently still being viewed. There also have been some update cycles regarding LTE4G. So we are currently discussing with Colin how to progress that. And I think these are the updates that have happened since our last meeting. Is there anything we missed or anything else anybody would like to add to this? Okay. All right. So let's start with our presentations. Hitoshi, do you want to share your slides? If not, I can also do it. Let me know.
Can you do it?
Yeah.
Yes, please. Thank you.
Yeah. Okay, let's start.
Okay. Okay, thank you. Okay, hello, everyone. This is a CCN info draft. So this is a version 6 update. So, info is an active networking tool and fully compatible with CCNX TLV messages, which are defined in RFC 8569 and 8609. CCN info is implemented on routers to forward and respond request, reply message, and consumers, which means the end user's program. CCN info discovers the path and content caching information in CCN such as reachability, hop count, RTT, on-path in network cache conditions, and so on, as well as multipath condition. CCN info defines the configuration for information disclosure. Next, please. CCN info request reply messages. So CCN info uses two message types, request and reply, both in CCNX TLV format. Request message consists of a fixed header, request block TLV, and report block TLVs. Reply message consists of a fixed header, request block TLV, report block TLVs, and reply block and sub-block TLVs. New CCNX type values are defined for CCNX info. Packet type, so two packet types, and top level type, one top level type, which is T discovery, and two hop by hop type, tdisk request header, and tdisk report, and CCN message type tdisk reply. Next, please. So this is a summary of the changes from 04. Actually, the latest version I just submitted yesterday. So but that version, the newest 06. But actually, we had a lot of comments from Dave and Paolo when we have been working on version 4. So from version 4 to version 6, there are many updates and changes. For example, we describe the differences from ICN ping and traceroute. We describe the differences from application level implementations. And we support optional CCNX validation algorithm and defined in RFC 8609 for both request and reply. We didn't mention this kind of specification in a previous version, which is 04. Now we support these optional values. And also, we made some consideration on incompatible routers and information provisioning. This one, I will detail many editorial changes. So the current version, I believe it's really good shape. Next page, please. So I picked up this section, consideration of the incapable routers and the information provisioning. So CCNinfo itself already supports something like administrative prohibit access control, and regarding incapable routers, we might not clearly describe the situation. So various part we include some description about incapable routers and the information provisioning. And I picked up section 3211, which describes the reply subblock TLV. For example, not reporting the following values such as object size, object count, and so on, shown in figure 16, that you should refer figure 16 on our draft, or do not report these values due to their policy. In that case, the router sets these fields to a value of 1. This means actually when a router who is not capable of reporting some values, such as number of received interest, or of these values according to the policy, receives a request. The router sets these fields to all 1. So this is something like a router hide, or router just ignores the reporting these values. The value of each field will be also all 1 when the value is equal to or bigger than the max expressed by the 32-bit field. So which means that if for example, the number of received interest is more than 40 billion, then we may have some conflict, but it's really rare case, we believe. And even so, if the CCNinfo user program might be invalid if these fields received are set to the value of 1. So we should care for that kind of situation. So we mentioned in several sections, especially in sections 3211. Next, please. So this is summary. CCNinfo, which is compatible with CCNX TLV format, is a really powerful network tool providing topology and network cache information, and reviewed by ICNRG members and other members. And we also provide a reference implementation that is included in the CEFOR. CEFOR is a software platform including forwarding daemons, CS daemons, sampler. So CEFOR is not just for CCNinfo, it's a full set of the CCN communication, and CCNinfo is already included as a standard as a default and standard implementation in CEFOR. And CEFOR is open source, and its license is BSD3 Close license, and it's fully compatible with CCNX TLV message. So it's really easy to use, and it's really good to use for your evaluation or enhancement of your or additional code. So it's really you can use. So I believe this version 6 is really stable. So now is the time for ready for last call. That's all. Thank you.
Okay, thanks a lot, Hitoshi. First of all, are there any questions? Anything on the chat? No. Okay. Quick question is, so the intended status for this would be experimental, right?
Yes.
Okay. Good. Yeah.
Yes,
so,
that's correct.
Okay. So this has been around for some time and has been discussed many times, and has seen quite a bit of review already. And Hitoshi and team already did some updates reflecting that. So yeah, we also think this is ready now, and yeah, would follow up on the mailing list regarding the last call. Of course, this only works if people really read it and provide their feedback.
Sure.
And I have someone in the queue. Colin.
Hi. Yeah, so I have to admit I haven't read the latest version. If this is targeting experimental, I just make the comment I usually make, which is that make sure the draft is clear what the experiment is. And what sort of experiments this? What sort of experiments is this helping support? What sort of research is this helping support?
So given that this is an instrumentation and management tool, would it be a, oh Jesus, there's that echo all over the place. Given that this is a management and instrumentation tool, would it be appropriate just to say that, you know, this is the tool you use when you're running experiments to do the measurements?
Yeah, I think that's reasonable. You just need to tie it back to, you know, if it's an experimental document, you need to tie it back to what sort of experiments people are doing and why it's useful to have this sort of tool. But yeah, you know, I think that's fine. I mean, it may also just be an informational document that describes, you know, that this is a tool to support the following experiments.
So I understand the intention. I mean, this is on the, say, level of ping and traceroute. I mean, that does a bit more, but so it's like a tool that enables experiments. So I'm not sure. Maybe that's what it should say then.
In that case, that's what it should say. Yeah.
Yeah.
I have a very basic question. So this draft requires registration. So because it's newly added several type values and so on for the CCNX RFCs. So is there any intention or is there any relation about experimental versus informational, even though we have a request for the IANA type value changes? There is no relation. So my question is, if the intentional status is informational, let's say, is it possible to request to change the new type value, a CCNX type value or packet, and so on, to the IANA registry?
You can put things in the IANA registries for informational documents, but this really ought to be experimental because it's got protocol elements that are being defined.
So this is really well, this is an operational tool and a management tool, but it's really the stage is really similar to the CCN. So this requires such kind of changes. So it may be better to continue as an experimental document.
Yes, absolutely. So I suggest that, I mean, Dave and I can work with you offline to find a good formulation for the research, for the experiments that this one enables.
Yes, and to be clear, I'm not suggesting you make significant changes here.
No,
If it's not already in there, I suspect this is a paragraph at most to highlight that this is supporting infrastructure for the various experiments.
Well, we have to get through RG last fall.
Sorry, I cannot hear Dave's comment well.
We have to get through RG last fall.
I think it takes a couple of
So my
seconds.
proposal is that we start a last call now.
Yes, please.
yes, we'll do that. And yeah, please, everybody, have a look and let us know what you think.
Yes, please. Thank you.
Okay, thanks again, Hitoshi.
Thank you. Thank you.
Let's move on. I think we have Yanis next. Yanis, do you want to run your slides yourself?
Yes, I can.
So. Maybe I have to stop sharing. Okay, yeah.
So how does this work? Do I have to? Okay, okay. Can you now see those slides?
We can see, yes.
Yep. Okay. Let me try to put it in full screen. Maybe things are going to blow up, but let's try it. You see something in full screen now?
Looking good.
Okay. All right then. Hi everyone. So welcome to this talk, which is much less kind of proposal oriented in terms of proposing a new solution for something, and much rather on like open problem statement and call for more ideas and actually proposals. So what I'm going to talk about today is what we call decentralized data delivery markets. And basically what this means is that it's how can we build a decentralized CDN based on a peer-to-peer network? Or in other words, how can we place incentives for fair exchange and fast delivery on top of permissionless peer-to-peer networks? So there are several sort of sub-problems into that, and I would like to quickly go through some of them. I think I have much more time allocated, but it's likely that it's going to be much shorter, so that we also have time for some Q&A. So let me try to kind of set the scene first, and so that everyone is on the same page. But feel free to interrupt if something is not defined. So we can envision a network where we have storage providers, like cold storage providers, and those cold storage providers, they have they store like encrypted copies of data that someone wants to publish. Then we have hot storage providers or delivery providers, and these are nodes that can provide fast access to the content. Cold storage providers can also provide access, but it's going to be slow because they have to decrypt. The content is very likely only stored in one of those cold storage providers, which might be far away, and so on. So the hot storage providers come in to kind of solve this problem. We can think of that as any kind of an entity in the network that has got some storage and can contribute to content discovery and content routing system. But also we need to have kind of algorithms to talk about content placement and content copy selection. So when someone requests some content, how can we get it? How can we get the closest copy? Of course, then we have clients that just click on something and want to download something, and we have publishers that want to put a copy of their data in the network. That could be a video, could be a document, could be a website, could be anything. So that's roughly what the high-level architecture could look like, and I'm going to come back to this later. But I would like to stay in this slide for a little bit. And the title of the talk is Decentralized, it includes the component of decentralized, which means, which probably requires some more kind of attention, and therefore the reason that we thought it's a good idea to present this to this group. Now, if we want to have something that a system where any user can actually set up a server and become a hot storage provider, then we're dealing not necessarily with trusted parties. So what is important then here is to have some sort of guarantees that when we make a request to the network and then we receive some content, we are being sent the content that we have asked for. This is because the network, as traditionally in most cases peer-to-peer networks are, there is no kind of DNS-like authority that we can say, is going to provide the right content. We can put some trust into it, and so on and so forth. And therefore, this kind of trust level has to be kind of passed into some other component of the system, which, in my opinion, should be something that can be put on top of content address data or name data, which this group is, of course, very familiar with. And therefore, I think that there could be good ideas discussed here. So trying to break this bigger problem down into smaller parts, we have identified, we've done this study a couple of months ago within Protocol Labs, and we have come up with these three different kind of sub areas of the problem. One of them is the data delivery metering and the fair exchange, which means basically how can we make sure that when someone is receiving some data, they're going to pay for what they have received, so that the hot storage provider is going to pay for the bandwidth and the memory and the CPU that they have used. The second problem is the distribution graph and how you form the network, basically. So you have nodes that spin up a server, they want to have, they have some storage, they contribute to the network, people go and publish stuff there. How do you kind of do content placement, content discovery, content routing, and so on? And finally, it's the economic model, which is very likely quite different to what we have today, because as I said before, these like different nodes are not really operated by a single entity, but as in a peer-to-peer network, anyone or Tor-like network, anyone can spin up a node and start contributing to the network. So there needs to be some storage, some economic model there that says this is profitable for those that contribute resources. It's sustainable for those that want to consume the resources, and so on. And of course, make sure that no one misbehaves on the way there. So I'm going to kind of go into these three a little bit and identify, talk about some challenges that we have identified, and basically open the discussion for more ideas or pointers that might have missed, and so on. So there are some desired properties here, which pretty much I have actually talked about. You know, we want to have things like, we want to have anyone being able to get in the system and start contributing. In terms of the metering and the first problem, as I said, the main topic here is, how can I make sure that I am going to pay for the content that I have received from the network? And therefore, there is a payment there which must only happen when the delivery happens, must only happen if the SLA that should be formed somehow is met. And then how can you basically make sure that no one misbehaves? There are several, the challenges and requirements here, kind of the attack vectors, if we want to put it this way, is that there is fairness. So we don't want users to receive content without paying. We don't want users to put hot storage providers to put resources into the network without getting paid. How do we avoid kind of spam attacks where someone is going to spin up a bot and just request a million times one document so that the resources of the other node are depleted, and so on. So this has been generally fair exchange has been, of course, a very well studied topic in the past, and it starts from the late 90s with e-commerce. So it's not a very new thing that is being identified here. Of course, experience, what the user sees, has changed from what very old studies have talked about and have assumed to what is being seen more recently. So we don't want to have non-user friendly setups, the transfer of data, whether it is real-time video on demand or whether it is a large file transfer. The transfer should start immediately. Ideally, it should be private as well, so that we don't have leaks into the network about information and things that the user is consuming as content on their browser and so on. And of course, performance. I mean, performance is now very different to the main body of work of when these studies were done. Now, we've done a literature review, and we have broken down the papers that we have read into these different areas. So there are different ways that someone can deal with that. There could be, paper packets, kind of approaches where every time someone receives some content, they have to pay back, and only then the next piece of content is received. So you can think of that as a kind of TCP packet ACK thing, where we only send the payment and only then the next chunk of data is going to be released. There is lock and unlock approaches, which mean that there is a request to the network, the client is sent the entirety of the file, but the whole thing is the key that decrypts the file, and that is sent last and is only sent if the request if the payment is done. Of course, there is always here the fair exchange problem of who is going to make the first step. And this is something difficult to solve, even in this day and age. Someone will have to pay first, and if the other party is willing to kind of screw them up, they can still do. Now, then finally, of course, there are advancements and more sophisticated ideas that have come up recently. These, I think, there are approaches such as zero-knowledge contingent payments that, where you can overcome many of the problems that were there in the past. Then there is optimistic fair exchange, which means that there is, like, the two parties transacting are not alone in doing that. There is somewhere a kind of third party, which both of the transacting parties have to kind of trust, but at the same time, the third party is not there always. It's there only if some dispute happens, and only then they're going to come in to resolve the situation. Perhaps there is some kind of collateral that is locked together in this third party, and there are penalties in case of misbehavior. And finally, there are well-known reputation systems where the kind of hot storage provider or the other party that you want to transact with is only chosen, based on their reputation, and therefore someone who is misbehaving or not meeting SLAs or things like that, they're basically never chosen, and therefore only those that behave properly participate in the network in the end. Now, this kind of summarizes the first thing. There are, of course, many more questions and much more depth to go in there, but perhaps it's more interesting to go to the second topic, which is the distribution graph. Like, how do you build the network, and what are the different strategies that are building the network in order to make this work from the network layer, network level perspective. So how's the network formed? How are requests efficiently routed? Where do you place content items, and how do you replicate them? So this is very important because, here we're talking about a CDN, and therefore it's not quite enough to say, okay, there is a copy of the network somewhere at the other end of the planet, because the delay to go there and come back is going to be very high, and that's not what we're used to nowadays. So there needs to be kind of a very interesting replication and smart caching mechanisms behind that can, in a sense, autonomously replicate content and put it, where demand comes in. These are the types of problems that are involved here. Of course, again, there are several desired properties. The content replication and caching, as I said. There needs to be an economic model. The economic model that I mentioned in the beginning, and I'm going to go into in a little bit, needs to support that. So all parties need to be in agreement when replication happens and extra storage space is included in the network. But of course, again, the system should be kind of permissionless in the sense, as past peer-to-peer systems that you can get in the network and start participating without kind of asking someone to kind of let you in. So in terms of the literature review, we've seen lots of past works here. There are many peer-to-peer CDNs that are actually in operation today, and they do deliver content. They're from past works from Akamai Net Session. That was, the first and very prominent kind of work that put peer-to-peer as a kind of complement to the more centralized infrastructure that Akamai is running, and there are many others as well. So this has been a good source of inspiration, but what we didn't find there is kind of how do you, all these systems always assume some centralized control over the network, like what is being published, where is being stored, how, if someone wants to get in the system, there needs to be someone that is going to let them in a sense, and so on. There is always the peer-to-peer video on demand literature, which what it did is basically it took things to the extreme from the point of view of having video on demand, which has got very strict requirements, and tried to find, investigate several different algorithms for to make it work. And if you make something work for video on demand, you basically are in a very good place, because there are very strict requirements, and therefore everything else is easier to do. And finally, we did a very thorough review of ICN approaches, that this good group, of course, is very well aware of, because it ticks many boxes on what are the requirements here and what we want to achieve. And as I said in the beginning, having named data and self-certified data is something that is very central, at least in my opinion, to building these sorts of networks. So several different well-known designs around that we went into more detail. Of course, the most straightforward thing to do is, there's a peer-to-peer network. Okay, there can be a DHT, very straightforward approach. Of course, there are pros and cons there. The DHT is very difficult to scale to very big numbers. It's very difficult to make as efficient as possible. And actually meet the SLAs that we want today. The same is for other systems such as PubSub, which is potentially even slower. Again, these things work, but we have to take into account the performance as well. Then there are name-based routing approaches that have been investigated in the ICN area, and they seem to be addressing many of the problems. So if you have some kind of hierarchical type of naming and you can do name-based forwarding, then many of the problems of that I mentioned before and many others can be solved. So you can do smart caching across along the path. You can have multicast and so on. So this, together with the data being addressed, seems like a very promising approach for that. And of course, then there are other types of approaches, such as DNS-like system, or the kind of name resolver that Cloudflare has been building recently and has released recently. So that's another very promising thing. Of course, the last two are the downsides. Kind of are in some cases they're less tested out there in the wild, and therefore there needs to be lots of testing before someone could build on them with high confidence. So there are several different kind of things, like on the technical side, that we went into. One extra thing to keep in mind is that we're talking here about a peer-to-peer network, and therefore I hope it was clear, it's like an overlay network. So it's not necessarily at the network router level, and therefore, how you manage that in terms of the traffic that is included in the network is something that needs to be taken into account. So if we have name-based routing, for example, where things are routed from one router in the network, overlay router in the network across a path, then this means that when in reality the direct underlay path would not be the same, then obviously you're putting lots of extra overhead on top of those overlay routers. So there is a tipping point there, I believe, where for say unpopular content, it could be resolution-based approaches, such as DHT-based or DNS-based or whatever, could get better results in terms of hitting the trade-off between performance and overhead in the network. But then from a point onwards, things are probably different for popular content. It is worth going the name-based routing approach and being able to aggregate requests and do all that great stuff. So so that summarizes the second part on the distribution graph. And finally, a few words about the economic model, which are not necessarily directly related with what this group does, but if we wanted to build this kind of permissionless CTN, then someone would have to take this into account. And what I believe is actually that, through some metadata that could live together with the content name, somehow these things could be, or some manifests that could be part of the system. These things, the economic kind of requirements, could be integrated into the network model itself. So very briefly, the economic model includes the kind of three different parts: the content providing economy, which is the content provider here who wants to store content together with some hot storage provider. Then what you have is the graph forming economy, and basically who, like as a hot storage provider, as a router, an overlay router in the network, who are the other pairs that you're connecting to. And this has got several different extensions there that I don't have the time to go to, but you can imagine the case, for example, where there is a content provider down here that stores the content with this storage provider here. I don't know if you can see my mouse, but I'm moving it anyway. And then suddenly the content becomes available in location C, the hot storage provider at location C, because of some demand from down here. So what do you do now? The hot storage provider has got a deal with the content, like in the content providing economy, with the content provider to say that, look, I'll be storing your content, and therefore you can be kind of paying me. The hot storage, what happens when we make the network be so that it would be better to replicate that to location C because it's closer to where demand is. So who is getting the kind of payment now for the services that they provide in the network? And, you know, acting rationally, of course, location C, storage provider, doesn't really care about the network, about the performance of the network. They just don't want to replicate content because they can use that storage memory for something else. At the same time, location A, hot storage provider, again, doesn't really care about the performance in the network and says, okay, I can serve all the content because this way I'm going to get all of the money from the, like all of the payment from the content providing economy, the content provider, and therefore, you know, that's in my best interest to do. But at the same time, you know, if you want to build an efficient like CDN in this way, this should not be like that. So there should be an economic principle behind it that says content should be replicated where demand comes up, and when this happens, perhaps the reward or the payment from the network should be split between these two, just as an example here. And then finally, you have the content exchange economy, which is the client and the storage provider that they interact with and how they pay. So, of course, depends who is paying for what in this model, if there is a content provider that is paying, if there is a user that is paying, or if it's a user that is paying on behalf of their provider. And of course, there are different use cases and applications, and both of these can be supported. So again, large body of literature here, and we did, you know, quite a bit. We split like the papers that we've read in different categories. These do not really, you know, they're in a different area, do not really link with ICN or content addressing necessarily. But the problem is that what we need to do is, as I said before, we need to link these two, and, you know, what at least we're looking to do is to link these two and have some sort of perhaps metadata or manifest files to leave together with content addressed data, so that we can indirectly embed economic principles into the naming structure or the metadata itself. And, you know, like having authenticated or self-certified data helps a lot with this, helps a lot with going away from necessarily location-based addressing as we've seen in the past. There are a number of attacks, only a few of them are listed here, but we can discuss further if you want. And yeah, I think this concludes my talk. There is this GitHub repository there where, you know, this was a very condensed summary of what exists in that website there. So yeah, please go there and contribute to the discussion. There is, let me see if I can go. Yeah, so this is the link. It's like a pretty long document, yeah, around like 20-25 pages. So yeah, but all this is like subject to others getting involved, and having more collaboration. So thank you very much.
Okay, great. Thanks, Yanis. So we planned some time for discussing this. Don't be afraid to ask your questions. So we have some questions in the chat already. I think I'd like to moderate this a little bit. So maybe let me first ask, are there any questions for clarification? So anything that you didn't understand and would like to clarify? So you can use the queuing system or add your questions to the chat window. So maybe one question to start with. So I think I will just start reading the questions here, and if people have other comments, we can also hear them. So maybe just on the fundamental motivation. So on your very first or second slide, you said, well, if you want to do content delivery on this permissionless P2P network, you have all kinds of challenges. So I mean, considering that, so CDN is widely deployed today, and also the economics are, I think, quite well understood. You could still argue there are some efficiency problems, especially like with multicast-like traffic. But so what is the fundamental problem that you would like to address with the system?
As compared to the economics of CDNs and content delivery more in general?
Yeah, so I mean, why would people need this?
Right. So the economic, starting from the economic model is different because, as I mentioned towards the end, you don't have a single entity that necessarily is on top of that. Now, why would people need this? It's a different kind of doing things, a different way of doing things, instead of storing data on, you can think of it as a Dropbox thing. So instead of doing that on Dropbox, you can do it on a more kind of permissionless and perhaps privacy preserving, more robust thing than that.
Okay, all right, thanks. So I'm switching between the queue and the chat, but I don't see anybody lining up. So maybe let's talk a bit about the, say, security and trust architecture here. So you mentioned things like self-certified names, for example. So what is the actual assumption on the, say, trust architecture, I would say? Who is certifying these names? So I mean, sometimes we use self-certified in a, say, kind of sloppy way. I mean, someone still needs to, want to map this to some real-world identity, perhaps, or there needs to be some other trust root. So what's the idea here?
Yeah, as I said, first of all, I don't really have answers to many of these. So I believe that with all the different applications that could be, could be applicable on top of such a system, I think there wouldn't be a one size fits all. So in some cases, there could be some identity like the username of some sort through a public key or something like that. That would be the identifier of someone, or differently in terms of data, it could be like what we've seen, like hashing through hashing the content itself and using that as part of the name itself, means that someone can basically later verify that the data they received is the data they asked for. So if you have some part of a hash as part of the name, then this kind of is an option to go forward.
Okay, sure.
But I certainly don't have all the answers. Certainly there are more, yeah. So
okay. All right. Yeah, let's look what else we have in the chat. So, Dave, do you want to ask the questions yourself? Should I read them? Is your mic working? Or?
Let's see if I'm causing echo. Am I causing echo?
Sounds good so far.
Okay. I think I may have resolved all my audio problems. So there's a general theme to the questions, which is the connection of security to the economics. There's some extreme points, like going all the way down the blockchain rabbit hole. And then there are other points which are what are generally called permissioned systems, where you sign up and you have have an identity that is understood in the context of the permissioning system that you use. But you seem to be advocating something that's in the middle there, and it'd be really interesting to get your views on whether you think there's some kind of stable architectural point in between those extremes.
Yeah, so you mentioned the fact. There is lots of echo.
That's sort of like a summary of a few of my questions, which I generated, incrementally as you were talking. So I was trying to summarize.
Can you repeat the two extremes?
So one extreme is you go all the way down the blockchain rabbit hole, right? And everything's anonymous. The system has no idea really what's going on, other than somebody's either doing a proof of stake or proof of work type of thing in order to do a transaction with the system, which is either to store something or retrieve it. The other extreme is a permission system where you sign up and you have an identity in that system, and there's some third party or quasi-centralized authority that keeps track of who is permissioned and who is not. Current CDNs work that way. There are obviously other types of entities that can do this. But you seem to be somewhere in between those, advocating something in between those two things.
Yeah, so I think that there should be basically different applications, and the different applications would have different applicability. Can you mute Dave? Right. So that's right. There isn't kind of one size fits all, in my opinion here. There certainly are applications where, could benefit from a blockchain type of thing, where some sort of identifier or, transaction identifier is kind of reported there and logged there. But again, I don't think that this would be, like sustainable to do for everything, all the content a user wants to request. On the other side, yes, there are some kind of more trust-based entities, but I would kind of put them more on the side of building an application. So if you're kind of, say, Netflix, and you want to publish your content, then you need to somehow have like have an identity on your system. Now, this, although this goes to the other side, it kind of builds on top of the base network setup. So yes, several different models should coexist, in my opinion, here. And although the network itself and someone wanting to become part of that would be able to do it, similarly as you can, start, in a sense, you can start an ISP today, and you don't need to kind of get permission. Well, simplistically speaking, at the kind of those who are transporting the bits of the overlay should be able to kind of get their gear up and start doing stuff. And, then building applications on top of that could stretch the system to the other part. But these two should be able to kind of interoperate both as regards, how do you request, resolve, transfer content, and who is paying who, how are transactions kind of aggregated somewhere or reported somewhere. I don't know if this answers your question.
Another sort of theme question is in a bunch of the slides, you dance around this question about how private is your information storage and retrieval. So you sort of dance around this whole big area of private information retrieval. You don't say things like, is it expected that the storage nodes don't know who's asking for the data, as well as third parties
Ideally,
not knowing
yes.
who's asking for the data?
Yes, ideally, yes. The system should provide that level of privacy.
So you're aware of the cost of that type of PIR, right? Which is somewhere between 500x and 10,000x a straightforward retrieval.
Yeah. I mean, this this is kind of more of a things that you realize that modern applications and users would require from the network, and therefore when you're trying to design something like that, you should take these into account, whether they are possible or whether they are they are performance damage there. Then that's fine. Tor has got performance damage, but many people use it, and basically I'm not aware of any great system that has providing privacy at the ideal level, at the desired level, and at the same time have the same performance. So yes.
I had a question in the chat too.
Sorry. So should I read the questions? Let me see.
No, I think we can moderate this for you. Dave, is there anything else you wanted to ask?
I can take a couple of the really detailed things offline with Giannis, because he made a claim that PITs introduce additional attack vectors, and I'm just curious what those might be, because I think all of them are already there with a fib and netflow.
With what? Sorry, the PIT introduces an attack vector.
We'll take it offline. I didn't get it because I thought any of the attack vectors would already be introduced by the fib and any kind of netflow style logging of what's already occurred.
Perhaps, yeah.
Georgia is suggesting a concept called proof of personhood, and there's a link in the chat.
Okay.
Just probably for your information. So a mechanism that binds physical entities to virtual entities in a way that enables accountability while preserving anonymity.
Okay. In terms of title, I didn't know that, so thanks a lot. I'll have a look.
Probably good for the minutes. So it seems to me, so there are kind of two schools of thinking. So when approaching this content distribution in say ICN ways, so say recent work in the say ICN environment. So for example, like the ICDN paper at last year's ICN conference. So this seems to start from say the fundamental ICN assumption, so that you have secured named access to data, and then you think about, okay, what do I need to provide some kind of approximation to what CDN does today? So, but in a say nicer way, so self-organized, say less manual traffic steering, and so on. So basically leveraging ICN principles. But so your approach here seems to come from the say other direction. So you seem to assume that there is a peer-to-peer network in the first place, and so you're sorting out the economics, and so then you're trying to plug in some content-centric or content addressing networking concepts to kind of solve the the data transport between caches or between nodes in the system. Is that a correct way to characterize it, or what do you think?
Yeah, the ICDN paper is great. Actually, it is a great paper actually, and was there was lots of inspiration that at least I got when doing this literature review. So it's very much along the lines that the paper talks about. I mean, it's been a couple of months that I read it, but yeah, it's certainly very relevant. So in terms of, I'm not sure I'm getting if there is already a peer-to-peer network and you're trying. So you can assume that there is. You can, I mean, this is kind of theoretical because it doesn't exist. So you can assume a T0 where there is, incentive to go and put some infrastructure out there in the network, and therefore the network is going to start forming in different locations.
I think we lost you, Yannis. And Dave, I can't hear you. I think you're probably on mute.
I was muted. I said, I think we lost Yannis.
I think we lost Yannis, which is a pity. Let's wait 5 seconds and then he comes back.
Can you hear me?
You're back. Okay.
Okay. So it was thrown out. Yeah. Okay. So I was talking.
Right. Someone lost you.
Okay. So yeah. So I don't know up to which point you've heard, but I'll try to summarize again. So there isn't necessarily the assumption that a peer-to-peer network necessarily exists already. What has to be there is that we can assume, since this is a kind of theoretical work at the moment, we can assume that at some point, once these things are sorted out, people would be get interested and say, okay, I can participate in this network, and then there could be users and servers and therefore overlay nodes popping up to participate in the network. So if your question was, does this peer-to-peer network already exist? Not necessarily. At least this study and literature review was not done based on some existing, I don't know, topology or other characteristics. Is that the question?
Yeah, kind of. I was more thinking more like in the theoretic approach. So this seems to be based on, say, primarily peer-to-peer concepts. So maybe the earlier ICN systems, like NetIn, for example, also.
Yep.
Right. So I was trying to make the point that I think there are these two different schools of thinking about the content distribution problem. And so I'm not taking any sides, just maybe trying to organize.
Yeah. So in the second topic that I talked about in the graph forming one, that's what I talked about when I talked about the tipping point. So if you assume the ICN the network level ICN approaches, then you can have a very nice kind of name-based forwarding scheme that kind of gets all the benefits of information centricity and content centricity. Now, if you say that, okay, this system works on the layer above as an overlay, then doing name-based forwarding between overlay nodes is going to inevitably increase the traffic that those nodes will have to transport through their machine, right? Because they're not on the path of the sender and the receiver. So for unpopular content, I think kind of resolution-based approach similar to past approaches like NetInf and similar things would be more performance efficient. But when popularity, for example, goes from a point on, even though there is some extra performance overhead, the popularity and the number of times that these will need to be transported in the overlay network would make it so that basically doing some name-based forwarding would be beneficial there too. So, but I would be very interested to hear opinions about that. That's only my opinion. I haven't done any simulation or pen and paper study, so
yeah, sure,
it's intuition.
Yeah. Yeah, it's interesting. So I mean, when they're looking at what's happening in CDN today, I think what you see is I mean, more and more hyperscalers moving out to the far edge, so one of the interesting challenges seems to be marrying CDN overlays with efficient kind of multicast like distribution. So for live TV, live video, and so on. And so you could say, I mean, so maybe the overlay approach is really inefficient here. You could do it in a different way. Do you also think that your approach would be able to address this type of CDN usage? So like multicast, like near live content?
Well, I don't know. There isn't any approach there. It's more of a wish list, to be honest, at this point. So ideally, I think if there were solutions to the problem areas that I talked about, then I think that would be a very good use case. Actually, that's very correct.
Okay, let me check the chat. Yeah, I see no other questions. Yeah, then thanks a lot, Yanis. It was an interesting discussion.
Thanks for the questions, everyone, and happy to answer more offline.
Okay, cool. All right, let's move on. So next we have Marie-José talking about new ideas for ICN and IoT. Do you want to run your slides?
I'll try to share my slides. I will not share my video because I have low bandwidth here. So I will just share my slides because if not, everything will freeze. So share screen.
I need to, yep.
Yes, I want to share my screen. Entire screen, allow.
Didn't work, it seems.
It didn't work? Okay, so then do it. You have my slides.
Okay. Just a second.
So maybe I will introduce why I wanted to do this. You gave me way more time than I wanted. I'm involved more and more into what I would call not your grandfather's IoT systems. And I think Schenk was on the call, and Schenk had written something for ICNRG some time ago about ICN for IoT. And I think this is like an old idea becoming new, just because of what IoT systems are becoming. So you can go to the next slide, because this is where I define what's happening, okay, in the world of IoT. As at first, a lot of the IoT systems, it was very easy. You were putting a lot of sensors, and you were just, from your web app or your web center, you would send a command, and the command would take a temperature or would take a single measure, and it was very simple, and it was really, it was doing it. However, the whole move to, I would say, autonomous systems, but not only those, have shown that the IoT is not for the cloud anymore, but it's a cloud edge. So this is actually something we've discussed in coin, but it is also something that's very much related to information-centric approaches, in the sense that it's all now very much data-driven with a lot of AI. So you're not asking just for a measure, you're asking for a bunch of measures that are following a certain pattern and will be used to improve on that pattern or increase the value of that data set. There's a lot of discovery, there's a lot of distribution of function, there's a lot of orchestration, this intermediation and functional decomposition. Actually, the previous talk mentioned some of that because it's related, and also security. And I call it the power of the and where. It is not anymore also, you don't want to know the temperature. You want to know the temperature when it is also related to something else. So maybe it's related to a humidity level, or it's related to a time, not just a time of day, but a time of day that corresponds to a wider measure. Like, I need to take these things once a month because this is what my industrial engineer recommends. Obviously, there's a ton of new applications. This obviously Industry and Agriculture 5.0, the whole healthcare and education, a lot of raising application and robotic and haptics, and all the big data applications that are running everywhere. And again, that means that when you send a command to your IoT system, you may not get an answer. You may get a bunch of stuff. It may be a picture, it may be a link to another element that could give you a better answer than the one that you asked. So this thing is becoming a lot of like a small information center network, in the sense that, there's a lot, and it leads into data discovery, data filtering. So much more, again, a information system than just what the original IoT was. And obviously, with this emergence of whatever 6G is, but a lot of people seem to be putting in 6G everything that the telecom industry forgot about 5G. And it includes all these computing and cache that are distributed in the network. And you do that to save bandwidth. You're not going to send everything at the same time because you would kill the network. So you store a lot of things locally, but then you need to find them. And all the new satellite networks, which are becoming a little bit more like a way to transfer that information from one point to another. But again, if you think about this, these things are IoTs in themselves. Next slide. So the target of all this research, I think, because there's a lot of it that is research, it's not something that has been resolved, because the current standard, which everybody that does IoT knows about, MQTT, which is a very simple pub/sub, and even what has been developed in more recently in CoAP, which is slightly more sophisticated, but it's still not what we would like to have. So it's a better edge that we need. We need this better edge to be intelligent and to be able to deal with the information. You want to have distributed computation, but for this group, it's not the computation that's interesting, but it's this decentralized orchestration and the security models. And that is actually something, well, it relates to the presentation before, but the security models are very evolved in ICN, and they're not very involved in current IoT systems. It's also this integrated edge network and cloud. It's more like a computer board where you have all these little IoT systems that communicate with one another. It's not a telephony network, and it's not a cloud, a pure cloud. So it's this cloud edge and this edge that supports the network, and the cloud and the network supporting the edge. Again, that case, for the better, I would say, handling of all the information that is being generated in the IoT system. So what do I mean? Maybe you can put the next slide, of which I could speak about for about 3 hours, but this is actually an IoT system, and it fits to a bunch. It's very small, and I know, Dave, you will complain about it, and I'm sorry. Yes, and the question is computation orchestrating data fusion. Yes. Actually, what this thing is, for people who don't want to go into my very small characters, the top one actually has this ICN thingy. But the thing is that what do we want from that system is the bottom is this data acquisition. And there needs to be a lot of decision-making locally. A lot of the current information in IoT systems, well, you can think about the autonomous cars, because they're the ones who are like the worst of that, because they generate an incredible amount of data. But even much smaller ones, if you start taking pictures, if you start taking more advanced measures, again, that correlate more than one sensor, a lot of that information is not interesting. You're not interested in everything. You're interested when something happens. Filtering and computation. I think filtering does decides what data you want to keep, and the computation actually works on it and may do some data discrimination and reduce the data by processing and not just by deciding which data you want to keep. So the features of these architectures are obviously intelligent controllers. An intelligent controller is something that is, again, data-driven. You want to have information-based queries, again, because you would like to not keep everything or just have the data when you need it and not all the time. You want to do your data filtering on metadata. That goes a little bit to the question about filtering. A lot of times data filtering is made on, it's based on the header, or it's based on the destination or the source, but you would like it to be on metadata. So that means when that thing was measured, how it was measured, which data set it relates to. There's obviously orchestration and computation. Again, for the data, how do you call it? You want to go from an image that is megabytes into a decision. So is this image the one I want to keep based on what I get it? I'll come back to your question, Dave. And then there's obviously local and remote processing, and I think this is related. Okay, I get the question you have, Dave. Throwing data away is a computation, but for me, maybe I'm too much connected to processing an image in this. I can decide that I want to keep this image because it was Friday at 2, but I may decide also to keep it because after I did my image processing algorithm on it, I found that there was a defect on the product. And for me, those are two different things. Next slide. So why ICN? Because what needs improvement? Haha. It's this interoperability that's needed between the edge devices themselves, and you should not always rely on distant cloud to make these decisions. You want to do them based on the information that is there and on the processing that is there and on the result of your data discovery. I see Dave frowning. I don't like it, but that's fine. And I think the main reason is that we need better pub/sub and data discovery. And because the devices are much more capable than they were before, and we can argue which functions we absolutely need, but we cannot disagree on the fact that you want to have queries and results of these queries that are going to now an information system, not just a measuring system, and that the current IoT that was developed based on just simple queries is not sufficient. And there's two ways to do it. We actually, at least in one of the projects that I'm working on, we're probably going to do our own, but maybe there's a role for ICN, which has a lot of the functionalities we need. And that's it. I think there's need for research there. I may put my other hat at one point and try to start that research, especially again, as it relates to a lot of stuff that people are talking about in haptics and robotics, which are also connected. But I think there was work in IoT in ICN, and I think maybe it's time to rethink about it and restart some of the research, because what I can see is that the IoT systems are not getting simpler; they're getting more powerful and even more data driven. So that's it. You gave me way too much time. I just wanted to throw an idea.
Yeah, thanks a lot. That was on purpose because we like to encourage some discussion. So please fire ahead.
Well, I think I tried to address David's questions.
I think we're just talking a little bit at cross purposes. So if you take a computation-centric view of the world, the fundamental objects are computations, and the data is just something that flows through the computation. If you take a data-centric view of the world, the data is the first order thing, and computing is some second order thing that happens on the data. And neither of those extremes is quite right. So the model I always have in my head is what happens at the LHC, right? Where it isn't a simple, oh, let's just throw most of the data away because it's useless. We have to do a bunch of computation to figure out what data to throw away. And this is a staged thing. So what happens very close to the sensors in the detectors is very different from what happens one stage back, two stages back, three stages back. And all of that, it has to do with what computation can be done where, as opposed to what data is where, because the data is going to be where the data is.
Well, I think it's
in many cases like industrial process control and physics and stuff like that, right? So you don't need to discover the data. You know exactly where it's going to be because you designed the system.
Actually, I disagree with you because you know where the data is, but you don't know the nature of that data, and you don't know how critical that data is to what you're currently do. And
I think
this is where
this would be an interesting conversation.
Yeah, because this is actually, I actually looked at this maybe from a different point of view. I looked at it more as a criticism of existing pub/sub in IoT. And the existing pub/sub in IoT is about asking a question and getting an answer. And it's a simple question that comes back with a simple answer. And the goal there is that you're going to, it's your Nest, thermostat, or it's you ask Alexa to play a song. That's fine. It works. If I'm an industrial system, I will measure the temperature. I will measure the amount of chemicals, whatever.
So let me sort of give you an extreme example of why I'm having trouble. I think it's a very simple question to ask. Did I just see a Higgs boson?
What?
Right? That's a simple question to ask. Did I just see a Higgs boson in my detector?
Okay, yeah, but
the problem is that that's the result of like tremendous amount of computation, not necessarily related to any particular piece of data. And what seems to be critical is not what data is where, but how does a computation obtain the data it needs to do its job?
And have you tried to do this with MQTT or CoAP? Because
What you
just
if
described,
my computation is running close enough to the things that actually generate and have the data, why not?
okay. It's not the well, maybe the boson is not the generic application, but I will tell you that what you described, first, I think finding bosons is not an IoT system, but that's fine. But I follow the thought. What I will tell you is that right now, in what is available if you do an industrial IoT system, first, there's no processing close to where the information is. You also have a lot of need, because of connectivity issues in that case, to accumulate the data in the system. So you know where it is, but you don't know. You may not want to download the whole database just to have access to one piece of information. And again, in systems that are outside, I would say, where there's a lot of bandwidth, you may want to have a way to do, well, I don't even call it data reduction, because at one point you may want to have access to the whole thing, but you may want also to interrogate the system based on a much richer set of information queries and creation, and to create a very much more rich data set than just what you would get by just asking a simple query. You may not want to know if it's a boson or not. You may want to know how the boson was created. I'm not in physics anymore. My original degree was in physics. But anyway, if you think, my question to the group was if there was a need to revisit ICN and IoT. You seem to indicate that no. I think to indicate yes. So maybe somebody else has a view?
What I was advocating is that we think of computations as first-class objects in an IoT and in an ICN.
Yeah.
As opposed to only data being the first-class objects.
Oh, okay. Well, then I agree with you. I think what I'm saying here, and again, there's echo. What I'm saying here is that the original way that IoT PubSub was designed was actually to get data. What I'm saying is, more and more, what you ask from the system is to do processing on that data, before answering you, to do some filtering, processing, learning, whatever you want to call it, on that data, and then reply to it. And that in your query, you should be able to send not only I want data X, but I want to know data X obtained through method Y, or I want to have data X if data Y, which is also from another form of data gathering, you should be able to publish your computation. So what I'm saying is that you need a much richer set of queries into both your data and your processing at the edge than what is currently being offered. And the sub could be a request to suit the computation, yes. And in the case of the system I have in my mind, it actually is.
Maybe let's address Luca's question. Have you seen that?
Luca, discovery problem. Well, of course, it is beyond IoT. And if you look, Luca, at the in my other group in Coin, all the data, all the discovery drafts, they're looking at a whole bunch of other ways of doing it, and there's also work being done at Ericsson in Sweden on how discovery is also based on semantic discovery, which is another interesting topic. And from the question about an actuator, the actuators are pretty dumb. So I would say that they also can do the sophisticated stuff that we want to do. Actually, we're not, and actuators are very simple processors. Maybe you want to have something much more. I have in my mind that, if I want to have an image processing response.
So, so I think there are really different perspectives on this, and so I mean, your presentation today is essentially, it's a kind of start of a longer discussion, I hope. And so, as Dave pointed out, so you can conceive these IoT systems in a way that you say, I'm trying to fulfill some purpose. I'm looking for data in the environment, and I need to find it and ways to access it. That's one way of seeing it. Another way is, so for example, if you think about like a data streaming framework, so maybe like Apache Flink or something, where you have functions in a graph, essentially, so directed graph, and so these functions know what they do. Somebody is kind of connecting those, and so they are kind of also told which input data, for example, to subscribe to or to access. So in that system, you wouldn't discover things, but still you would like to benefit from the ability to put functions at convenient places, and then let the system figure out the connectivity itself. And
yes. So and actually, this is something that also IoT systems go into industrial or agriculture or things like that, and a lot of times you would like not to replicate all functionality everywhere. And what you're saying is interesting, because maybe one node has it, and what is available. Francois, yes, I wanted to have IoT use cases in the presentation. Sadly, I'm working on another proposal for a big IoT system, and once I'm done with it, I will have a very, very nice use case. But I had hardly time to breathe in the past 2 weeks, so I will. It's my plan of showing how a current system is limited compared to what could be much more interesting. So thank you, Francois. This is very much in the direction of what I would have liked to do, except that I didn't have time.
Yeah. Phil removed himself from the queue. All right. So I would say let's follow up on this. Would probably be good to talk more about specific scenarios. So also alluding to the recent comments in the chat. And well, I still think there's some really interesting potential, also really new perspectives that are emerging. So let's do that. Thanks again for this discussion starter, what do you say?
Thank you, and thank you everyone for allowing me to do this. And again, sorry that I didn't have much time to make it better, but I will get to it. Thank you.
Okay, thanks. Do we have Jörg on the call, or? In that case, so Dave, as the co-chair of the ICN conference, would you like to talk to?
Yeah, hi. So I just want to publicize the fact that our annual conference is coming up. We're now on the eighth iteration of this. And for the research community, this is kind of the premier venue for getting your work on ICN related topics through the review process and published and presented. So the conference is the end of September, 22 to 24, as it is every year towards the end of September. And please note carefully that the paper registration deadline is at the beginning of May. So you have 2 months to put together a super paper if you haven't already. And could you go to the next slide? Because this year we've expanded the call for papers with some suggested areas that we haven't necessarily emphasized so much in the past. So I want to say that the typical kind of stuff that you'll see on routing and security and congestion control and caching are obviously still very much high interest research topics. But we also want to solicit work in more visionary work, architectural papers about potential new ways of thinking about ICN and scoping new research in the area. And also looking backwards, now that we have over 10, going on 11 to 12 years of research in ICN on systematization and knowledge papers, looking backwards and seeing what we've learned and how we can characterize and systematize the knowledge that we've gained in the research over the last 10 or so years. Plus, since we've seen a lot of activity in computation as well as just content recovery, that's been a topic that's been increasing over the last few years. That we're continuing to emphasize, and I think there's a lot of opportunity to do new work there. Measurement and management, and again, another topic that we want to really encourage people to think about now that we have a solid technical base is what are the more economic, soft, political, sciencey, and economic aspects of what ICN can mean to not just the networking community, but to the computer science community as a whole. So please consider submitting your work. We use Hot Crap for the conference management. If you take a look at the program committee, it's not just the usual suspects. We have a pretty broad participation, not just in the ICN community, but broadly in computing. So, so please, let's make a really good conference this year. It will be virtual, but we're hosting it out of the École Polytechnique and the Cisco Systems Paris Innovation and Research Lab in Paris. So thanks very much. Let's move on.
Great, thanks. Yeah, looking forward to a really nice program again this year. And yeah, this brings us to the end, by the way. Thanks everybody for attending. Yeah, we'll follow up regarding the last call. Please help us getting this ready. Yeah, please keep on doing all this great work and presenting new ideas to the group and writing drafts. Hope to see you again soon. I think that's it. Bye, everybody. And thanks again to Cedric for taking notes today.